Good afternoon, everybody. Welcome to today's chem lesson. Today we're going to talk a little bit about condensed structural formulas, building off of some of the things we've talked about in our previous lessons, in our previous videos, where we looked at naming and drawing these structures. We're going to look at today at condensed structural formulas, which is another way of writing these structures. And so when we talk about organic molecules, right, I can say C6H14, right? That is enough information for me to draw a number of different pictures, right? C6H14 can be 6 carbons in a row and all of the associated H's, right? That's C6H14. It could be some version of this molecule with a branch on it. Right, that can be C6H14. It can be some version of this molecule with 2 branches on it. Right, I can draw. Nope. A branch here and a branch here, and this is C6H14. Right, C6H14, just telling how many C's and H's are in a molecule isn't enough information for you, the person receiving the information, to know which of the any number of different molecules it could be. Right, it's not enough information for you to know, is it this, or is it this? And so we use condensed structural formulas, which take C6H14 and write it out in different ways to give you a better idea of which molecule you're talking about. Right, and I'm going to draw both of these and we'll take a look at what these look like, right? So C6H14 can be written out any number of different ways, right? These are 2 examples of how we would write this out, right? And if we can count 1, 2, 3, 4, 5, 6 C's, and 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 H's. And we can do the same thing here. 1, 2, 3, 4, 5, 6, right? Sorry. 1, 2, 3, 4, 5, 6 C's, and 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 H's. All right, so both of these contain 6 C's and 14 H's, but they're showing us how to connect them. They're telling us, based on the way they write the C's and H's, how to connect the pieces so you have a clearer idea of what picture you should draw or what molecule you should have. The first compound is hexane, just plain and simple hexane. 6 carbons in a row, all single bonded. The second one is a branched hydrocarbon. Right. So, if I'm looking at this condensed structural formula and I want to know a little bit more about how to draw it, I'm just going to write it bigger here. Right, I want to know a little bit better about how to draw this thing. I'm going to draw it from left to right exactly the way they tell me to. I'm going to have a C connected to 3 H's. I'm going to have a C connected to 2 H's. I will have a C connected to 2 H's. I will have a C connected to 2 H's. I will have a C connected to 2 H's. And I will have a C connected to 3 H's. That's all of my pieces. That's all 6 of my C's and 14 of my H's. And now to make sure everything is connected, every carbon needs 4 bonds. So I'm going to connect this carbon to the next one, connect this carbon to the next one. All right. Emily will get there in a second. If there's a double bond or a triple bond, we'll see how that looks. All right, so this is hexane. 6 carbons in a row, all single bonded, filled in with H's. Right. And based on the condensed structural formula, I knew how to connect those pieces together. Right? It's about connecting, looking at what they give you, reading it left to right, drawing it left to right, and then whoop, connecting them through. If I look at the other example that they have given me, right, this one over here, CH3, CH, C2H5, CH2, CH3. Right, I'm going to draw exactly the way I did before, right? A C connected to 3 H's, a C connected to 1 H, 2 C's and 5 H's, a C connected to 2 H's, and a C connected to 3 H's. Here, it's a little bit more complicated. Now, if I want to connect these pieces to each other, right? I can connect this, that makes sense. I can connect this, that makes sense. But now I've got a connection and a connection. I've got 2 missing connections from this carbon. I've got 1 missing connection from this carbon and 1 missing connection from this carbon. I have to figure out how to connect these pieces together. And a hint to us is that they bunched up C2H5, indicating to us this is probably a branch. So if I take this piece and I connect it up top, boop, it leaves me able to connect this through to the rest of the chain. I'm going to clean that up for us. Right. Right, so that C2H5, if I squeeze that up a little bit, that can be connected along the top, and this can continue the whole chain. It's a branch with a single bond here, right? There's no double bonding happening, right? Because this is not connected to the same carbon twice, it's connected to 2 different carbons. If I draw this again a little bit nicer, it's going to be this molecule, which is still 6 C's and 14 H's. Right? But our condensed structural formula helps us look at, this is very different from just 6 in a row. It helps us figure out how to connect our carbons together. It tells us how to clump our pieces in a way that gives us information on how to then draw our final molecule. All right, let's take a look at one that has a double bond in it. So now, again, I've written a condensed structural formula. So I'm going to go from left to right and draw out my pieces. A C with 3 H's on it. And as I'm doing this out, I'm going to tell you, right, you start to recognize patterns as you look at these, right? The CH3s are usually caps, right? So they're either at the front or at the back. CH2s are going to have an H above and below. If they're clumped together like we saw before, C2H5, that's almost definitely a branch. And you start to pick up on some of the patterns here. Right, so here I've drawn all my pieces as they have told me to from left to right. And now it's about connecting my pieces together. I can connect straight through. Right, that works perfectly. Zoop, nice straight line. But here, this C is still missing a connection, and this C is still missing a connection. And so the way we're going to fix that is by connecting them to each other. Right, putting a double bond. Putting a double bond right there. And now every C has 4 bonds. All of our H's are like, we can't just add H's because they told us how many H's there should be. We can't just add C's because they told us how many C's there should be. So if we're going to change anything, or if we're missing anything, it's got to be a double bond or a triple bond. Right, so if there's a double bond, it's apparent by the way they give you the H's, right? If it was single bonds, this would be CH2, CH2. If it was a triple bond, this would be C and C, right? But if there's an H missing from 2 things right next to each other, they're going to be double bonded together. If there's 3 H's missing, from each of these things, they're going to be triple bonded together. And so we'll see that in a second. I'll show you another with a triple bond. Right, so with CH3, it's going to be our cap, our front or our back, right? The engine or the caboose. It took me a long time to come up with the word engine there. Right, the front or the back of our carbon chain. CH2 is going to have H's above and below for single bonding. If we have just CH, right, there's likely a double bond or a branch. And if we have just a C, it's likely a triple bond. That's not P. Or 2 branches. Right, and context clues, right? The other things they give you will help you determine, oh, that's a double bond, right? Here there was nothing else for me to add, so it must be a double bond. But if I had, a random CH3 or a C2H5 or some other clump of C's in between here and here, that could have been branches instead. All right, so let's try one more. Context, Serena. So I'll show you in a second. Based on the positioning, so we knew, for example, that this... Nope. Oh, it's upside down. This way. We knew that this piece was a branch because there was no way for it to connect into the bigger chain. C2H5 only has one place it could be connected to, right? It can only get something else over here in this really bold line. So it can't be part of the chain because that means it needs to be connected front and back. So this has to be some offshoot because of the only because of where I can connect it. Right. So for example, let's look at another one. If I wanted to do C2H5. No, let's not overcomplicate just yet. Right, let's look at this one. And then I'm going to make them a little bit more complicated as we go. I'm thinking we do another couple practice problems. This is all I really wanted to get us through today. So we're going to look at a couple more of these. Right. Here, if I look, right, our patterns still hold true. Our CH3 starts us off with our cap, or our front. And we've got a CH2, 1H above, 1H below, another CH2. We have just a C, followed by just a C, followed by CH2, followed by CH3. Sorry, I don't want to write that. I want to draw that. All right, so I drew all my pieces. Everything that they told me is accounted for in my drawing. And now my final thing is to figure out how to connect all of the carbons. Right? Straight through is going to be my first move here. This carbon has 4 bonds. This carbon has 4 bonds. This carbon has 4 bonds. This carbon has 2 bonds. 2 bonds, 4, 4. So these are both missing 2 bonds. I have nothing else that I could add to them to help balance them out. So I'm going to connect them to each other a total of 3 times so that they have a total of 4 bonds each. Right, so we're looking at these formulas that they give us, reading them left to right, drawing them left to right, and then making sure that all the carbons have 4 bonds. All right, I'm going to do one more. The CH2s aren't double bonded because they connect left and right and up and below, right? So if I have a CH2, it is going to have a connection this way and a connection this way. So it doesn't need to be double bonded because there's going to be something over here and something over here giving it 1, 2, 3, 4 bonds. It can't have a 5th bond. It will never have a 5th bond. It can only have 4. Right, so I gave us a little bit more of a tricky one here. We're going to do the same exact thing that we did before. We're going to draw each piece out. We have CH3. CH2, CH, CH, CH2, a C by itself, a CH3, a CH3, and a CH3. Alright, so those are all of my pieces, so I can rest assured that now I can't add anything to this other than bonds. So I'm going to add some bonds. I'm going to connect left to right. Perfect, 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 perfect. And hold on just a second. This can't connect to anything else. So I can't add to connect this CH3. I can't add to connect this CH3. So I got to do, there's something missing from these two. 4 bonds, 4 bonds, 3 bonds. There's a bond missing here. 3 bonds, a bond missing here. 4 bonds, this one's fine. 2 bonds, not great. There's 2 bonds missing here. And then here, these are each also missing bonds. There's a lot of bonds missing in this one. If we look at our patterns of things we know, CHs are likely a double bond or a branch. They didn't mention any branches over here. So this is going to be a double bond, and that makes both of these happy. A C is likely a triple bond, or 2 branches. But I can't triple bond to this carbon. I can't triple bond to this carbon. So it's not going to be triple bond, it's going to be 2 branches. Oh, look at that. We got stuff that needs branches. So we're going to connect these 2 things here. One below. And that makes this happy. All right, we moved that. And this goes up top. All right, and I know that they're really long lines, but they're still fine. All carbons are now happy. All carbons now have their 4 bonds. We didn't add any C's or H's. Right? We still have our, I'm going to change fonts a little bit here. Right? We've got our C. We've got CH3. We've got CH3. And we've got CH3. Right, we didn't add any extra carbons or hydrogens. All that they told us here is what we drew. Right, nothing extra, nothing missing. Right. Structural formulas, right? Condensed structural formulas are just a little bit more more puzzly than some of the other things, right? So it's still draw them left to right, and then see how you can connect your pieces together. Right. And then I see your question there, Ellie. So, not by, when I said they don't mention any branches, I'm talking about the condensed structural formula, right? They just read this off from left to right. Right? And they say CH2, CH, CH, CH2. Right? If there was going to be a branch there, it would have come in between the 2 CHs or after one of those CHs, right? They're telling you how to connect the pieces. If there was, actually, let me just do that. Hold on. I can rearrange this to give us a little bit more of a hint here. I'm going to stick with this purple, though. CH3, CH2, CH, CH3, CH, CH3, CH2, C. CH3. Right, does that make me happy? Pause. 3, 2, 1, 1, 2, 1, 3, 3, 3. All right, so, sorry, I just wanted to double check myself before getting started here. So now if I draw this thing from left to right, CH3, CH2, CH, CH3, CH, CH3, CH2, C, CH3. Right? When I connect my pieces now, they want me to do the same stuff I've been doing, which is connect left to right, left to right, left to right, like that. But now, right, I can't do what I did before and connect my CHs. They mentioned, right, when I said that they didn't mention any branches, right, here they tell me CH, then a CH3, then a CH2, or sorry, then a CH, then a CH3, then a CH2. So they tell me that these are branches that are going to go above like this, H, 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 and then this will connect in a straight line, and then this is a branch, C, H3, and then this will connect through in a straight line. And then, yeah, I was wrong. I knew I was wrong. That's got to be a CH2 at the end there. Right, so it's the structure of their form. I can't say that sentence the way I want to say that sentence. It all depends on the order of the C's and the H's. Here, by just saying CH followed by CH, there's no mention of branches. There's no CH3 or C2H5 or any number of C's in between them. So there's nothing that's going to come in between these two things, because that's the way condensed structural formulas work. They read from left to right. They are drawn from left to right. And other than moving for branches, it's a straight line. Same thing here, except this time they said CH, CH3, CH, CH3, CH2, CH2, CH3, right? They mentioned those branches in this section here, right? CH2, then a CH, and then here just another CH, but down here they say here's a branch, and then another CH, and then a branch, and then a CH2. Right? It's very much methodical. Organic chem for us is very, very methodical. It's left to right. It doesn't always have to be specifically in that order. But there will always be a path you can follow. There will always be something that you can look at and say, oh, if this is all that there is, there must be a double bond here, or this must be a branch that attaches here, or these must be double bonded while there's a branch on the other side over there. Right? There's always going to be something cluing you in your condensed structural formula. All right, so next time we're going to take a look at things that aren't just basic hydrocarbons, right? Everything we've looked at so far has just been C's and H's. There have been no O's, no N's, no F's, no other elements at all, right? Everything's just C's and H's, just C's and H's for this whole time. And so on Monday when we come back, we'll look at things that are more than just hydrocarbons. We're going to look at table R, which is our functional group table, and go through a little bit of what these different words represent and how we use table R and how we go through the naming of those things. But for now, I'm going to transition us into tutoring and office hours. And I hope you all have a fantastic day.